Okay, can you see my slides?
Yes, madam.
Okay, we're supposed to learn BJT today. However, I will start first with the hadith in Bukhari. The Prophet Muhammad sallallahu alaihi wasallam said, "Inna khiyarukum ahasanukum akhlaq." The best among you are those who are the best in akhlaq. So we have 15 or 18 today, including me. 18 tolak satu Anas, 17 confusing of us all together today. And the Prophet said the best among us here is the one with the highest akhlaq. Okay, so akhlaq is very important in Islam. And nowadays, sometimes people, and we need to know what akhlaq. It's not the akhlaq that we, what do you mean? That we think we understand. It has to be akhlaq from what Islam says. For example, being brave in the class is a good akhlaq. Being shy in a class for the true things is not a good akhlaq. That's one example lah. There are many more. For example, to say bad words, right? I think nowadays, I don't know. Saya nak tegur lah student engineering especially. I think, but maybe student lain lagi teruk, saya tak tahu. On the wording that you use among yourself. When you talk to each other, what words do you use? The Prophet Muhammad sallallahu alaihi wasallam, our role model, never come out from his mouth anything bad, or nothing comes out from the typing. Tapi Nabi Muhammad tak pandai menulis. If he can write, nothing bad will come out from the typings, from Twitter ke Instagram ke. Because I saw my friend, another lecturer, snapshot. Saya tak ada Twitter. I don't have a Twitter. Then there was an issue on the COVID-19 in the university, in the mahalla, and then there are comments from the students. So one of the comment, I was shocked reading the comment. So because the student was using the F word, fool, and the other shocking to me is nobody in the thread like advise the brother not to use the bad word, as if using the bad word is normal. Even the situation is as bad as is really bad, but from a good akhlaq, you don't say bad words, the F word, whatever word lah coming from us. So that's something not right. And there's another hadith which I don't share here. A good akhlaq stems from a good iman, solid iman. If your akhlaq is not good, it means that something wrong with your iman. So first we need to improve our iman in order our akhlaq will be improved. And that's why those who have the best of akhlaq shows that he or she has the best of iman, and she is the best among all people. Okay, so let's strive to be somebody with good akhlaq and have knowledge. We need to have knowledge. What Islam says about akhlaq. Is it culturally akhlaq that we understand, that we understand, or is it really Islam? So if you want to know whether it's cultural, ikut tradisi kita ni, or is it from Islam, we need to know that where the source of the akhlaq coming from. Is it from Quran? Is it from Hadith? Or is it your mother, your grandmother said so? Okay. I'm not saying it's bad that your grandmother, but we should differentiate which one from Islam and which one come from nenek moyang kita. Okay. Ni yang lama ni. Okay, I want to first talk about Andalusia. Okay, anybody have been to Andalusia? Do you know where's Andalusia? Oops.
Spain.
Spain. Okay, which part of Spain, Haris? Why your video is not turning on?
Yeah.
So everybody has to turn on, right? So I will kick you out.
South, near North Africa, I think.
south near North Africa. I mean, where is Andalusia in Spain? Oh, betul-betul lah. South of Spain, you mean?
Yeah, south of Spain. Yeah.
Okay. Good. Right. So today I will what do you know about Andalusia? Okay, that's the third question. What all of you know about Andalusia? I'm scrolling.
Right.
I can see some people not turning on the video. Why? You have internet problem or what? Although I'm doing slideshow, can still see, you know.
Madam,
Yeah.
sorry for interrupting. Tadi Muhaimin ada masalah sikit. Ada orang call dia tadi, so dia disconnect. So dia tekan
Okay.
terbalik link. So dia minta Madam approvekan.
Okay.
Terima kasih.
Saya dah approve. Okay, sama-sama. Okay. Who knows what do you know about Andalusia? So please,
It used to be.
in the meantime, write down your name in the chat, okay, and metric number for attendance. Yes, who wants to say something?
Right. It used to be a Muslim country.
Muslim country? Andalusia is a Muslim country? Or
Yeah. A long time ago lah. Not
was?
now.
Was.
Yeah, was. Yeah.
Okay, what else? Mirza, why your video is not turning on? Ni saya tengah baik hati lah saya tanya kau tak sakit je. Syed Zarif,
Stable, madam.
Mirza Ashraf.
My internet connection is not stable, madam.
Dah kenapa awak tak beritahu saya? Kenapa awak senyap sahaja? Kan saya dah beritahu. Kan masuk kelas saya, one part of the adab, you cannot turn on, you have to tell me.
Okay, madam. Sorry, madam.
Saya tak ada mood dah tidur. Let's have a 5 minutes break. It depends whether make doa so that my mood is okay again. I will come back. Okay, let's continue. I think regarding the Andalusia, you can read on your own. So no need for me to share. Let's go straight to the BJT. Okay. Okay. So BJT, what is bipolar junction transistor? It's a type of transistor. When you say it's a transistor, it must have a 3 terminals. Previously, we learned about a semiconductor device which having only 2 terminals, right? The P and the N. So that's the simplest of the semiconductor devices. Next is we have transistors, and there are a few types of transistors. The most common and basic ones are the BJT, bipolar junction transistor, and also MOSFET, metal oxide semiconductor field effect transistor. Okay, so in this class, you'll be learning both the basic of them. If you go outside now, they are using advanced transistors, but the basics are coming from these two. So there will be some slight modification of the advanced or more technological device. However, the basics are these two. So if you understand these two, if you go outside later, when you work, you will understand if you read a bit more. So that's why in the university, we don't really teach, we should introduce you, but we don't teach all the advanced ones in the undergraduates. Why? Because the technology will keep on improving. So there will always be a new transistor, a slightly new transistor every time. But in order for you to understand the new advanced one, you need to have a fundamental basis, asas. So this is the basis. When you go out, if you read more advanced, you will know, you will be able to understand. Hopefully lah, inshallah. Okay, so this is the history of the BJT. Basically, but you can read it on your own. But basically, it's a story between a researcher, okay, and then there are a few people who accidentally, it's not what they want to do another experiment, but they realize that it comes out that this suddenly becomes another device. So if you can see the photo on the right here, so it's just like they just put a wire to a piece of semiconductor and then to another piece, and then suddenly they have something that looks like a transistor. When they do they measure the electrical characteristics, the current voltage. So then they patented it, so you can read the rest. And then this William Shockley, so they win Nobel Prize in 1955. These people, and then Shockley later quit to start a semiconductor company, and then it go bust. But then one of the staff from Shockley went on to invent the integrated chip, and he founded the Intel Corporation, the one that we have now, the advanced everything are based on integrated chip. So historically, BJT was found first before MOSFET, because if you see now everything in Intel, not everything lah, most of the things of the integrated chip are from MOSFET. The basis is MOSFET. Then they have CMOS. But historically, BJT was they orang jumpa BJT dahulu. So but later on, can you guess why? Kenapa nowadays everything are on MOSFET and not BJT? Although in terms of kau kira the advancement of transistor, BJT jumpa dulu.
Low power consumption.
Low
Power consumption.
Low power consumption.
Sebab because MOSFET we have only one current, but for BJT we have two current. When we have only one current, then we can reduce the power consumption because power P equal to I square R.
Okay. Power consumption maybe, but the biggest reason is because we can make the MOSFET small, very small. BJT technologically, they haven't found how to make as small as MOSFET. Okay, in terms of the power consumption, maybe there is, but not significantly to be number one. But the number one issue is because MOSFET we can make small. So you can see here, the first BJT is actually very big. Kenapa saya punya dia hang? It doesn't want to move. Peliknya. Do you see that? You don't see it moving, right?
Yeah, it's not moving. It's only the cursor moving.
Okay, it's okay. I think I will stop sharing and share again. Tak tahu kenapa. This is technology. It's not really reliable. That's why there will always be research, and there will always be another version. If you buy the iPad, this iPad, there'll be another version because there's always room for improvement. And also technology, you cannot trust 100% technology because technology can be manipulated. You know, we don't know all your whatever you have now. Now it's yang Farhana share tu kan. Now it's very, everybody are talking about privacy, security. Previously, nobody cares. As long as we can talk to each other, it's fine. But now, coming with the big data and everything, right? People can process a lot of data. Previously, manually, we human, we sleep, we eat, we go and talk to our friends. But the computers, they don't eat, they sleep, they just keep on churning numbers. So then they come up with the artificial intelligence. They know they teach how the computer how to think, how to sort things and to find things that are important. So data become precious commodity. Previously, who cares, right? Who cares what Hazim is eating today? Who cares what Monira was buying yesterday, right? So, but now, that's important. What Hazim eating today, Monira shop yesterday, Why? Because they can predict who you are, and what you're going to do. So it's now the war on prediction. So if I know everything about Afiq, he likes to play games, maybe his chair is a gaming chair. So and he likes blue color, maybe he likes jersey, play sport a little bit, maybe not sure it's sports or no. See, just by reading. So this is not even yet the information that we can get. And then if we know that, we know how to tackle Afiq. So, so I can give if I give you free present, maybe Munira say, I don't like lah, why you give me like e-sport? I like handbags, for example. But Afiq, I give that, or definitely you will eat my bait. And this is what's happening now. And it's a shocking when, apps for Muslims are also they're also selling the data to the military. So US, now kita start balik share. Betul. Sebab and ramai orang tak tahu pasal ni. Kita lah mangsa-mangsa tu. And the scary is the Muslim Pro apps pun, and many apps actually selling our data to the third party. Bila third party tu, we don't know who, and this third party will sell to another party. And that's what happens to the Muslim Pro. So it's scary. That's why try to switch off of apps if you are not using it. Just tutup the apps. Okay. Oh, now you can see. So you can see here the transistor looks very big. I remember when I was in Italy for 2 months. That time I was lepas A-level, saya buat A-level dekat UK. Lepas tu dia ada bagi Commonwealth country ni boleh pergi sama buat sijil dekat European country. Dia bayar kita orang duduk sana lah. So I think at that time I was 17 years old. Budak je. And then but my parents allow me, so I went there with my friend, a Muslim. Semua yang pergi tu British lah. And when we went there, and we went in Italy, we had to work. Dia letak kita tempat, apa namanya? Tu Alhamdulillah Allah jaga. Saya pun kadang fikir-fikir masa muda dulu, banyak benda-benda yang menakutkan yang saya buat. That many things can go wrong. Tapi Alhamdulillah Allah protected me all the time. So that's why, whatever you do, ask the blessings of your parents. Allah will protect you. Kalau you do something against the will of your parents, payah hidup awak nanti. So I went there for 2 months, and I remember we living in a house sharing with the Italians. Tapi dia orang perempuan lah, satu rumah perempuan. Tapi sebilik saya pun ada orang putih perempuan juga. So and then I had to work in a school yang dipanggil Euro Sekolah, and nobody speaks English there. So I had to learn Italian. So if you know Italian, boleh cakap Italian sikit dengan saya. But the thing is, we went to a museum in Italy, and UNESCO punya museum. And the man there, Pak Cik kat situ, orang tua Itali tu sangat baik. Dia boleh cakap English. Kebanyakan manusia masa tu zaman 1999 kot. Ataupun 1998, tak tahulah umur berapa masa tu. At that time I was in Italy, and then we went to this museum, and this pakcik very old, can speak English. He's showing dia kata one of the first transistor, BJT transistor. You know how big it is? Ni satu transistor, this big. Dia macam tube, banyak tube susun jadi komputer, bilik tu komputer. So huge. And now you can imagine, now one transistor you cannot even see with your own eyes. So that's how technology progresses. So previously all transistors were big, okay? And then at one point somebody discovered MOSFET. Then there's a technology competition between VJT and MOSFET. Dia berlumba. And then in the end MOSFET takes over. So sebab dia lagi mudah nak buat, and then bila ramai orang buat, so teknologi tu push forward, so BJT become obsolete. Bila tak ramai orang pump money, duit tak banyak untuk buat eksperimen, so therefore people pump on MOSFET, that's why, and then dia ada kelebihan tertentu, that's why in the end now everything on MOSFET, and one of the biggest reason because you can make it very small. Okay. So that's so you can see here the point contact transistor, the first transistor ever made. Ni 3 orang dapat Nobel Prize tu lah. Ni William Shockley ni, Bardeen dan Brattain. Rasanya dia orang ni orang UK ke US, tak tahu. Tak pasti. New Jersey ni US kan. Then apa namanya? This is the transistor. You have your base, your emitter and your collector. So 3 terminal. It looks very crude lah. This is like the first thing that they found. Then later on they perfecting it to become the semiconductor BJT that you know today. So okay, we talk about 2 main categories of transistors. We have the bipolar junction transistor and we have the field effect transistor. And as mentioned, transistor have 3 terminals. And what's the main difference between these 2 transistors, BJT and FET, is how it works. Okay, which is what we are learning in this class. Kan kita belajar how the PN junction work. Later you will do assignment how LED works, how apa nama ni, solar cell works. And the main, although both BJT and FET, the application are roughly similar. Both can become amplifier. You learn in your first year, right? Both can become amplifier. Both can become a switch. But 2 application. Tapi how actually it's amplifying and how does it become a switch is really different. Okay, so the physics of it is different. So we'll be learning in this class, inshallah. So in analog circuit, transistor are used as amplifier and regulator. In digital circuit, transistor can use as switches, logic gates, random access memory, microprocessor, and many more. Okay, my question to you. Anybody knows kenapa nama dia bipolar? Anybody wants to guess?
Because the end of the junction is same, so it's bipolar.
What is the same?
The end.
The end?
Each end of the junction.
Each end of the junction is the same. Oh, macam NP, NP, NP macam tu.
Yeah.
That's why it's called bipolar. Okay, good attempt, brother. Good attempt, but it's not right. Anybody else? I admire your bravery. So, other than Anas?
Because it consists of electron and holes.
What consists of?
Because electron is negative and holes and positive, so bipolar.
So why MOSFET tak nama bipolar juga?
I don't know.
Kenapa yang ni je nama bipolar? Good, close but not really right. Other people? Saya tak nak fikir, madam. Saya belajar je BJT macam first year dulu. Semua saya hafal, madam. Okay, now you're in your 4th year and your masters, patutnya kita tak hafal lah. We should understand everything that when you understand everything, it's easier to remember. But if you just hafal lah, if you just memorize, it's difficult for it to stay in your mind. Quran pun macam tu juga. If you understand what Quran says, the meaning of it, it's easier for it to stick inside your heart. Tapi kalau baca tak tahu maksud, more difficult. Right? Betul tak saya kata? So, ni tak cek hafazan lagi. Semua hafazan bagus lah. I am student. I remember Prof. Faris. You know Prof. Faris? Professor Ahmad Faris. He was our dean last year. And then sebelum ni, lama-lama dia jadi dean tu, dia tak ada apa, jadi deputy rector, jadi dean balik. Sekarang dia deputy rector balik. Have you met Prof. Faris before? Professor Faris, Ahmad Faris. Yes,
Yes.
Jumpa kat mana?
I learned statics with him.
Statics with him, right? What do you think of him? Siapa tadi cakap?
Me.
Mi tu siapa awak ni?
Haris.
Haris? Mana Haris? Haris tak, kenapa awak tak ada video?
Saya ada.
Tak ada, kosong, tak nampak. There's no video.
Pelik. Ada lampu semua.
Semua orang nampak tak Haris?
Hello?
Tak.
Tak. Tak ada orang nampak Haris. Saya nampak kosong hitam je. Baru nampak. What do you think of him?
Dia macam a bit flamboyant lah.
Flamboyant? What do you mean?
Dia macam happy go lucky macam tu.
Tak berani nak sebut betul-betul kot. Okay. So Prof. Haris, kenapa saya tiba-tiba cerita pasal Prof. Haris? Kita tengah cerita pasal apa tadi?
Hafazan, madam.
Hafazan, yes. Prof. Haris ni, he actually a very good leader. Saya respect sangat Prof. Haris ni. Dia sangat cerdik, very smart. Kalau nak tengok orang cerdik and dia boleh fikir cepat, awak cakap dengan dia. Then you realise dia punya speed, memory, dia punya CPU laju yang teramat. Out of many lecturers or many professors that I met, Prof. Haris ni memang Allah bagi dia cerdik. And dia critical thinker. Janganlah duk tipu dia. He will find out. So and he said when he was a dean, he said we should have in IIUM sampai sekarang tak ada macam like a characteristic. Maknanya when you go out of IUM, you have memorized at least a certain surah or ayah. Which is bagus lah. Sekarang ni macam tak tahu. Bila keluar grad pun tak tahu apa karakter IIUM pada diri awak. So I remember he said so. So I think very good. The way he thinks. And he's actually very very smart and a very good leader. Kalau nak tengok pemimpin yang baik, amanah dan cerdik, tengoklah Prof. Haris. Dia memang macam tu. Dia memang tak kisah apa orang kata. Flamboyant. Awak katalah apa kat dia. Dia bantai awak balik. So semua lecturer takut kat dia. Sebab dia, because you takkan menang lawan dia sebab dia cerdik. Kalau cakap dengan orang cerdik ni, and really smart, you need to be very careful. Okay. So kita cerita pasal hafazan ni sebab kita kata kena faham lah kan, jangan menghafaz saja. So bipolar, the name bipolar because how the transistor works. The name MOSFET also, MOSFET comes from the meaning of the structure of the MOSFET, metal, oxide, semiconductor. Dia ada 3 layer, metal, oxide, semiconductor. Field effect transistor. Field effect tu pun how it works. Field effect transistor. Bipolar junction transistor, junction because it's a PN, there's a PN junction. So that's why the name junction. Why the name bipolar? Because the currents, current inside the transistor are due to both electron and hole. The current inside a BJT is due to both electron and hole. But in a MOSFET, the current is only either due to electron or due to hole. So dia maknanya pada satu masa only one type of current there is in a MOSFET because how it works. But BJT, remember in your first year, the calculation for BJT is much more complicated, right? Do you remember? You have many equation, IC lah, IB, betul dia macam really complicated because how it works also more complicated compared to MOSFET because there are 2 currents. So you need to you need to calculate the electron current, you need to know how the whole current. So that's why the name bipolar. Bipolar means you have two polarity of carriers inside the apa nama ni, inside the BJT, which is electron and hole. Okay, now you know. Okay, now let's go back to my, kita patut habis pukul apa? 9.20 kan? Okay. Okay. Alright, so okay, ni dah. So bipolar because both carrier types play important roles in the operation. Carrier types means electron and hole. And actually field effect transistors are unipolar. Ini kita bipolar kan. Unipolar because it depends on a single carrier type. So it's either electron or hole. And this is the unit, the symbol that you normally see for BJT. So you can have both NPN or PNP. Okay. Now we want to learn how the NPN and PNP works. Okay. So there are three terminals. We call it collector, base, and emitter. Ini semua first year engineering. You learn this during your first year. And this just to show some pictures of modern transistors. Tak ada, saya tak tunjuk pula gambar of the historically transistors. The big is a vacuum tube besar. Okay, but nowadays transistor can be very small. BJT can be made either discrete devices or in a planar integrated form. Do you understand what this means? This sentence?
Yes.
If you are quiet, it means you understand. I don't have to explain.
No. No, madam.
Do you know what discrete devices means? Discrete. You know?
Specific.
Huh?
Specific.
Yes. So roughly macam tu lah. Sebabnya kalau discrete ni, it means that you can make one by one. So one transistor, two transistor, ni kaki dia. 3 transistor. So this is called discrete. So it's packaged one by one. But planar integrated, planar means in one you have BJT over here, and you have a PN junction over here, diode over here. You can have BJT again over here, MOSFET over here. That's called planar integrated form. Basically, in one substrate, you have multiple devices. Discrete devices means satu-satu. One. Okay? Ada soalan? Tak ada soalan. Okay. Kalau tak faham, tanya tau. In discrete, the substrate can be used for one connection, typically the collector. Okay. You understand what substrate means, right? Kalau tak faham, tanya. Kalau tak, saya go on je. Okay, anything that you don't understand, ask. Okay, so in an integrated version, meaning this planar integrated form, all contacts appear at the top surface. Contact dia kat top surface. If it's discrete, normally at the substrate, the collector will be connected to the bottom, to the substrate. Just how it works, how we make it in real life, macam mana kita nak buat tu, ni duduk cerita pasal tu lah.
Madam,
Yes.
madam boleh macam lukis tak?
Lukis apa?
Yang tadi dia cakap substrate, bawah sambung apa tadi tu. Nampak?
Ni dia.
Oh, okay.
In substrate. Okay, so kalau ni is in a planar form. You can see, so this is the emitter, base, collector. So dia ada 3. So biasanya kita akan draw macam ni. Kalau biasa nanti kita akan draw macam ni. N, P, N. Right? Kalau kita draw, we want to explain. But in actual life, when you make it macam kuih lapis tu kan, yang kita buat betul-betul kat kedai tu, kita buat, factory buat, dia akan bentuk macam ni. So dia akan bentuk macam ni, tapi sebenarnya ni samalah dengan ni. So you have the N, you have the P, you have the N. So this is N, P, N. This is the emitter, and then you have the base, you have the collector, right? Because in real life you cannot make it like this. Tak boleh nak buat macam ni. You kena buat macam ni. Okay, so this is what's it meant. Okay, Muhaimin.
Okay, madam. Terima kasih.
Sama-sama. Alright, so normally they say the emitter based diode. Okay, we will see kenapa dia panggil diode. Anybody knows kenapa dia panggil emitter based diode? Kita duk cerita pasal transistor, kenapa dia kata diode?
Because emitter base dia NP, bila NP jadi diode.
Yes. So maknanya kalau kat sini tadi, so sebenarnya ni P, ni emitter, ni base, ni collector. So di P ni N, you have a diode like this sebenarnya. And then ni P dengan N, you have another diode like this. Betul tak? So you have 2 back-to-back diodes, PN junction. Sebab tu nama dia junction. Okay, so yeah, so the emitter based diode is closer to the surface. Then the base to collector junction, because it's easier to make the heavier, ni salah spelling, heavy doping at the top. So maksudnya ni biasa kalau yang ni yang integrated, kalau yang discrete, yang discrete yang ni mungkin ada kat bawah sini. Okay, so nak buat in order for you to make what do you call it, to make a dope higher, it's easier for it to be at the top. Dia nak control tu senang. Nantilah saya explain. Nanti saya explain. You need to know that kenapa emitter is, sebab kalau kita draw macam ni, awak rasa macam okay, apa nama ni, sama je doping dia kot, right? This is N, P, N. So the doping of the N might be the same of the P and the same of the N. No. Engineer ni dia cerdik. That's why the first thing we should understand how it works. Once we understand how it works, we can tweak. Then the engineer or the researcher or the scientist realize, in order to make it more efficient, we need to make the emitter region here, the N over here, doping higher compared to others. Okay, we will learn this why later bila kita belajar how it works. So actually awak boleh cerita kat saya kan, sebab dapat tengok video yang bermacam-macam. Anybody wants to explain how the BJT works? Structurally lah, yang macam tu dulu. Yang P ke NPN yang macam tu dulu, bukan energy band diagram. Siapa boleh cerita? Okey lah madam. Saya ni tak boleh bercakap. Tak apa, okey, saya assume awak semua awak semua tahu. Tanya saya soalan kalau ada benda awak tak faham daripada video tu. Kalau tak tanya soalan, saya assume awak tahu. And sebab awak pun tak nak cerita how it work. Kalau tidak, saya boleh tegur lah awak kalau awak faham tu salah. So now I take the approach, I assume, I trust you that you understand since you are not sharing. But I also give you the chance to ask me question if there's any. Okay, tak ada soalan. So saya skip lah, tak payah ajar lah BJT, awak semua faham dah tak? That's great. Make sure you score in the exam. Tak ada soalan. Betul ni saya skip. Saya akan skip. So semua faham. So I will skip, brothers and sisters, since all of you are great students that you watch videos, you already understand everything. I will not go through how the BJT works. That's the core of it. So 90% or I don't say 70% of the BJT is on how it works. And I will not go through that because saya tukar sikit cara, saya suruh tanya soalan ataupun share how it works. But you didn't ask, you might be in trouble. So in the future, tak apalah, you choose that path. So I won't go through that, but there are things I will only top up things that maybe you didn't. I didn't ask you to find out. For example, I assume that you know how it works. If you know how it works, tell me why do we make the emitter the highest doping? If you cannot answer that, biarlah. I won't answer it as well. So awak tak tanya saya soalan tu, awak tak tanya saya soalan, awak faham. Awak nampak ada point yang saya nak bring out ni. So why the emitter has the highest doping?
So that the electrons from the emitter can make the jump across the base.
Why don't you make the hole in the base, you know, the acceptor doping, the P dope, because now we're talking, let's say we talk NPN here now, right? NPN. So if that's your answer, right? Then why don't I make the base, the P doping higher than the N of the emitter? So saya make hole dia banyak kat situ.
Sebab takut dia recombine dekat sana, lepas tu dia tak ada current across it.
Takut siapa recombine?
The holes and the
Okay, it's a good attempt, Harif. But I won't tell you the answer. Pergi cari sendiri ya semua. Why you need to know the doping of emitter, base and collector. What's the amount of doping concentration and why? I will put note to myself to make sure I ask you in the question somewhere. If you understand how BJT works, you should be able to answer. Dia macam ada lah sikit Haris. Kalau jawab macam tu dalam exam, saya bagilah awak 60%. Okay, kalau tak jawab langsung, 0%. So at least, you know. Okay, so. Alah, dia hang lagi. Stop ya. Share lagi. Ini semua awak dah patut tahu. Okay, you should also know why the emitter is the highest doping and why the base is very thinly and lightly doped. Okay. You need to understand. Bukan sahaja menghafal. So you can hafal later recombination. What does it mean? Why you want to have less recombination in the base? Okay. Ni cerita ni, tapi there's no much explanation. You go and read somewhere. And in order to answer this, you cannot read one textbook. 3-4 textbook lah. So the point I want to make here, you can actually have an easy route. I will teach you everything. Or you go to the difficult route, go and read 5 textbooks. Okay. Now you have chosen yourself to go for the 5 textbooks. So because you don't want to tell me how it works and you don't have question, so tahniah lah, you'll be reading the 5 textbooks. So find all this, make sure you know of this and what's the reason. And if you still don't get the answer, make sure you ask me in the next class. Okay, that's how we're going to have the class after this. Sebab kita kena sendiri nak belajar. Kalau saya duduk suap je, you know, one of the problem with our society, our Muslim society, and especially Malay lah, masalah dengan orang Melayu ni, kita ni suap, you know, spoon feed. Everything we've been used to spoon feed. Semua nak dapat subsidi. So kita jadi orang yang malas, kita jadi orang yang tidak kritikal, kita jadi orang yang cekap. So, and benda tu jadi habit dah sebab awak dah di spoon feed daripada kecil. Mak awak suapkan awak, mak ayah awak sediakan semua benda untuk awak. So, awak tak pernah hidup susah. So, that's why we are not trained to be critically think and really fight for what we want. So, jadi, ni saya nak push awak lah. Saya buat ni bukan sebab saya benci ke apa, I want to push you. You know, when I was studying in UK, cara dia lain, cara dia tak spoon feed. Saya kena struggling to get that. And then tapi dia akan guide dengan persoalan. Saya tanya soalan, dia guide sikit. Saya tanya soalan, dia guide lagi. Saya tanya soalan, tapi saya kena tanya soalan. So, tapi maknanya tak ada tiba-tiba dia kata, okay, saya akan ajar semua. Tak macam tu lah. So, and then it makes me think. So, benda tu train me how to think. And the problem with the Muslim community now, kita tak berfikir. Which is Allah kata banyak dalam Quran pasal ulul albab, orang yang terbaik itulah orang yang berfikir. So kita kena start fikir. Okay, so I will tell you what to think. So go try to get the answer. Apa lagi ada? So make sure you remember the 3 operating mode of a BJT here. What is it? And every time, how does it work? Physics of it. Bukan hafal ni saja. So you should know in the forward active mode, what is it actually? How do you bias it? Number 1. Number 2, where the hole, electron hole dia pergi mana? Dia buat apa? Generated ke? Recombine ke? Swap ke? Drift ke? Diffusion ke? Okay, because the basics I already teach you. So normally for active mode, you use it as an amplifier. Saturation, you use as a switch. Cut off, you also as a switch. 10, 10, 10. You use saturation cut off mode. In order to amplify, you use forward active mode. Ni semua benda sama, boleh baca lah. So make sure you know diffusion ke tak diffusion, drift ke. Jangan tersilap tau, jangan tertukar. Kalau kita tukar drift dan diffusion, when you explain, saya cut 50% terus. Sebab tu basic. Okay, current gain. Bagus juga, senang saya nak ajar macam ni. Saya tak ajar banyak. Awak kan pergi baca sendiri ya. So, next is energy band diagram. Also, I ask you to read. Anybody wants to explain how the BJT works in energy band diagram? or have any question? Okay. Nobody wants to explain. No question, it means that you understand. Saber husnuzon. So you understand. So I don't have to explain everything. You can answer everything perfectly in the exam.
Madam, I have a question.
Okay, yes, Munira.
Munira first.
Okay, I have a question. For energy band diagram, what I have discovered is two mode, active mode and zero bias mode. Is it the active mode is same for forward bias and reverse bias?
I'm trying to understand your question. So you are saying, is the active mode, which is the forward active mode, sometimes the name is forward active mode, is the same as the forward and reverse bias?
Reverse active mode, is it the same as the
the reverse active mode, yes. Yeah, dia sebab dia mirror lah, dia NPN, PNP is mirror. So dia terbalik macam tu, macam ni, you terbalik macam itu je. So it's the same, roughly how it works. Okay, good. Lagi ada soalan?
Saya nak tanya yang under PN, energy band diagram under PN, yang forward bias. Macam dekat link YouTube tu, dia ada bagi lukisan kan, dia lukis energy band diagram, and masa dekat dia macam mana antara balance band dengan conduction band ada Fermi level.
Oh,
And then
cakap
ada
English
satu,
lah, cakap English.
hello, okay. Yes. Supposedly there is Fermi level in between conduction band and valence band.
Okay. Not supposedly,
Okay.
it must have. Okay.
Must have, okay.
Okay.
Then there is an additional level which is called intrinsic Fermi level. I want to know more about that. Intrinsic Fermi level.
Okay. What is, okay, good question. I'll ask you back. What is Fermi level? We covered this before. Buka nota. Other people can also answer. What is Fermi level?
The probability of finding the free carrier.
Yes, the probability of finding free carriers. So how many Fermi levels you should have inside an energy Venn diagram?
1.
Okay, 1. Good, 1. So now, panggil Amirul ke panggil Faris ni?
Mana-mana boleh, madam.
Awak suka yang mana?
Amirul.
Okay, Amirul. So dalam Islam kan, Nabi kata kalau kita nak panggil orang, kita kena panggil orang dengan nama yang dia suka. So ada orang panggil kawan dia panggil, I don't know, acap ke apa kan. Kawan-kawan sama, dia suka ke orang panggil dia acap? Dia rasa tak apalah madam, semua orang dah panggil saya macam tu. Tapi kalau kita kawan yang baik, kita patut tahu lah dia suka ke tak. Macam Khadijah panggil apa? Cathy. Dia suka ke tak? Kalau dia suka tak apalah kan. Tapi kalau dia tak suka, jangan panggil. Okay Amirul. So apa tadi? Perlu ada satu. So jadi
Intrinsic Fermi level.
Okay. So now you're asking dekat P ke dekat N ke dekat intrinsic material now?
Both P and N.
Okay, let's say P first. Both P dengan N tu intrinsic ke extrinsic?
In the YouTube video is in intrinsic.
P dengan N tu intrinsic?
Yes, it shows both of the P and N side is intrinsic Fermi level.
No, tak kira itu ke apa. Apa kefahaman awak? P dengan N tu intrinsic semiconductor ke extrinsic semiconductor? Okay, my next question is what does intrinsic and extrinsic means? Sebab kalau tak jawab tu, maknanya awak tak faham lah apa tu intrinsic dengan extrinsic. Siapa nak jawab?
Intrinsic is not dope. Extrinsic is dope.
Okay. So P and N, is it intrinsic semiconductor or extrinsic semiconductor, Amirul?
Intrinsic semiconductor.
Afiq, P dengan N, is it intrinsic ke extrinsic semiconductor?
Extrinsic because it's dope with P or N.
Okay, Amirul, awak dengar tak Afiq jawab apa?
Yes, madam. Because of the doping.
Yes. So P dengan N tu dia extrinsic because we dope it. They have extra carrier. So that's why I'm asking you. So now you're asking me the P dengan N, where's the Fermi level, right?
Yes.
So should it have an intrinsic Fermi level?
It should have.
It should have.
Yeah.
Okay. I think saya tahu kenapa awak confused. Saya ni sikit lukis sikit. Tak salah dah tu. Betul. Tapi I will tell you kenapa our discussion, kenapa saya tanya macam tu tadi. Can you see? Okay.
Yes, madam.
Right. So for this extrinsic semiconductor, this is a p-type material. For example, p-type material over here. This is the conduction band. This is the valence band. And you know, p-type semiconductor is extrinsic semiconductor. Therefore, where's the Fermi level should be for extrinsic semiconductor? Where does the Fermi level should be? Should be where? Kat mana?
Valence band.
Apa yang valence band?
Close to the valence band.
Okay, should be close to the valence band. So this is the Fermi level of the p-type. Now the question is, okay, before any material, before any extrinsic material to be extrinsic, is it intrinsic before? Faham tak soalan saya? Sebelum mana-mana extrinsic semiconductor menjadi extrinsic, adakah ianya intrinsic sebelum itu? Wah, translate bagus saya.
Yes.
Yes, it should be like that.
It should be right. So everything is pure until you add impurity. So
Impurities.
So sebenarnya starting dulu dalam history ni dia ada, kita ambil color lain pula. Best main color ni. Okay, so sebenarnya dia asalnya dia ada this intrinsic Fermi level. Tapi once you the I, okay, ni acceptor. Boleh nampak lah. So apa nama ni? Starting everything have a intrinsic Fermi level. And then when you dope it, you have the doping, the Fermi level of the acceptor or the donor. Now, when you're redoped the material to be P or N, majority of the carriers will be due to the doping. Insignificant the contribution from the intrinsic. Saya rasa saya pernah cerita sebelum ni, dia ada dua-dua, maknanya you can still have hole being excited from conduction to valence, but most of the hole over here are coming from the doping. But so at normal condition, room temperature, most of the contribution for the carriers are due to the acceptor. Except at a very high temperature, then you have more and more of the hole will be excited to go to the valence band. Now, I think your question to me, apa soalan awak tadi, Amirul?
My question is, why is intrinsic Fermi level is there.
So adakah saya telah menjawab?
Yes, madam. Absolutely.
Alright, thank you.
Thank you, madam.
Next question, if there is any. Alamak, 9:22 dah tak ada. Okay, tak boleh lah. Yes, Afiq?
From your slide 48 and slide 49 and slide 50 a little bit confused me, to be honest.
Don't trust my slides. Kan saya kata dah sebelum ni. So maknanya kalau nampak benda confuse, yang percaya kat mana 48 ni?
49 band diagram for active mode, and then after that but the next slide after that is shown NPN for active mode. This part is a little bit confusing to me.
Kenapa awak confused?
Because like from the explanation that I watch, should be like on the slide 49. So I'm confused, like what does slide 50 means?
Slide 50? You are confused of slide 50, 50?
Yes.
Slide 50 is on PNP. 49 is on NPN. So apa yang confused?
Oh, because like, wait, because like on the slide 49 that I have, it's shown like a band diagram for active mode, and then like and then the slide 50 is just this one diagram.
Oh, okay. So maknanya mungkin numbering saya kat sini tak berapa ni dengan awak. So you are confused about the band diagram, the active mode dengan NPN FAM tu?
Yes, correct.
Okay, apa yang awak confused?
How I confused about the second diagram.
Okay, so apa yang awak confused on the second diagram?
How does it become like this?
Okay, good question. Anybody can answer? And then I can assure you both diagrams are correct. Tapi kenapa dia berbeza? Okay, sila find out. Let's answer that in next class. Afiq, make sure you remember to bring this back again. Okay, kalau awak semua tak boleh jawab soalan tu, maknanya awak tak faham lah. Inna lillahi wa inna ilaihi raji'un in the exam if you can answer this. And then you don't ask. So thanks to Afiq, dia tanya at least. So have a think and we'll have this discussion in next class. Let's close the class. Thank you very much everybody. So remember, saya nak push awak untuk berfikir dan bercakap dalam kelas. Kalau tak bercakap, tak tanya, you will suffer. So kita terpaksa buat macam tu. Cara baik-baik ni dah tak jalan. Kita kena cara askari, military pula. Okay, siapa-siapa boleh baca doa? Pun kita tak keluar lah kalau tak ada nak baca doa. Voluntary. Dari siapa tu?
Afiq.
Afiq dah pernah baca kan?
Dah.
Siapa yang tak pernah baca, ada tak yang tak pernah baca lagi? Sebab semua orang kena jadi ketua keluarga kat sini. Nak kahwin, walaupun Amirul dah kahwin. Ramai nak kahwin. Siapa yang nak baca? Iqmal. Okay, silakan Iqmal.
Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alamin. Wassalatu wassalamu ala asyrafil anbiya wal mursalin wa ala alihi wasahbihi ajma'in. Allahumma ighfir lana dhunubana walwalidina warhamhuma kama rabbayana shaghira.
Amin.
ولجميع المسلمين والمسلمات والمؤمنين والمؤمنات الأحياء منهم والأموات برحمتك يا أرحم الراحمين. اللهم ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. صلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين.
Alhamdulillah Rabbil Alamin. Jazakallahu khairan Brother Iqmal for the doa. May Allah accept our doa. Amin ya Rabbal Alamin. InsyaAllah see you in next class next week. Oh, next week cuti. Okay. So make sure kena prolong lama sikit dah. Ilmu-ilmu ni jangan delete lah. Jangan buat dosa. Dosa will delete this ilmu. So try to not make dosa so that ilmu tu retain. So kalau saya lupa next tu saya akan tahu awak buat dosa. Okay, so and then jaga mata, jaga hati, jaga everything. Tu dosa pun can come from the mata and hati. So insyaAllah please work on the assignment. Sebab tak lama lepas tu you need to present. Let's close with tasbih kifarah and suratul As. Subhanakallahumma wa bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal asr innal insana lafi khusr illa alladhina amanu wa amilus solihat wa tawasaw bil haqq wa tawasaw bis sabr. Okay, assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Terima kasih, Madam.